Bismillahirrahmanirrahim. Assalamu alaikum ji. Today we will start with Bayesian learning. Bayesian learning or Bayesian inference is a very broad topic that we can offer 2 semester long courses to cover it. Here we will learn the foundational concepts so that you can build on these basic concepts later. We will use these concepts to understand and develop machine learning algorithms. In particular, we will focus on naive Bayes classifier. Okay, the outline would be we will start with a very brief introduction of Bayesian learning framework, moving towards maximum a posterior estimation and maximal likelihood estimation. And then we will talk about, we'll show that linear regression is indeed uh, a maximal likelihood estimation. And finally, we will talk about naive Bayes classifier. And we will also cover a couple of examples to understand naive Bayes classifier. Okay, I will be using this chapter 6 of the book Machine Learning by Tom Mitchell. And you can consult the book for more details. Okay, overview of the Bayesian learning framework. In machine learning, the idea of Bayesian learning is to use the well-known Bayes theorem to find the hypothesis function. In the video on probability theory overview, we derived this Bayes theorem, and we also used Bayes theorem to solve one example. I assume you have understanding of what Bayes theorem is. Okay, let's take an example to understand this Bayesian learning framework. For example, we want to test the fairness of the coin. So we give you a coin and we want to test the fairness of the coin. If you use frequentist statistics approach, this approach includes that you conduct trials and you observe heads to compute the probability. Right? Confidence of estimated probability of head increases with the number of trials. You conduct trials, you observe the heads and the number of trials. Probability of head would be given by the number of heads you get divided by the total number of trials. This is an estimate, right? And obviously, as you keep on increasing the number of trials, the confidence of this estimate keeps on increasing, right? Determining the fairness of a coin by using the probability of observing the heads. So this is a frequentist statistics approach, or this is frequentist viewpoint. So in here, we have not used any prior information, which can be very valuable to improve our hypothesis. For example, we could have used information that the coins are not made biased intentionally. By design, the coins are not biased. Right? This is the information we have, but in frequentist statistics approach, we have not used this information. And this is the only difference from the Bayesian learning view. In Bayesian learning, we assume that we'll start with an assumption that probability of head is equal to 0.5. So this is coming from our past experiences. We call it a prior information we have, or these are the beliefs we have about the probability of head. And when we conduct experiments and when we get observations, we adjust the belief according to observations from the trials. And we can have a better hypothesis by combining our beliefs and observation. It is this thinking model which uses our most recent observations together with our beliefs that is known as Bayesian learning. So the Bayesian way of thinking illustrates the way of incorporating the prior belief and then incrementally updating the prior probabilities whenever more evidence is available. This is not the case for frequentist statistics approach. So each training data point contributes to the estimated probability that hypothesis is correct or incorrect. This is a more flexible approach as compared to learning algorithms or as compared to frequentist statistics that eliminate a given hypothesis that is inconsistent with any single data point. In Bayesian learning, unlike frequentist statistics, we can end the experiment, we can stop conducting trials when we have obtained results with sufficient confidence for the task. Okay, so this was a very brief overview of Bayesian learning framework. In the next video, we will formalize this mathematically.